Hello everyone. The next part in the remainder is Wilson's theorem. Okay, so in the Wilson's theorem, okay, first of all let's start with the question. Okay, let's say I want to find the remainder of 12 factorial when divided by 13. When 12 factorial is divided by 13, I want to find the remainder. Okay, so there are rules in the Wilson's theorem. So before that we will do this question manually. Okay, so now we know the value of 12 factorial is how much. The value of 12 factorial is 1 into 2 into 3 and so on till 12. Okay, let me write this: 4 5 6 7 8, okay, 9 10 11 and 12. This is the value of 12 factorial. Okay everyone, we are supposed to divide this by 13. Okay, so now the task is you are supposed to make a pair of two numbers in the numerator such that when we divide that pair by 13, the remainder has to be plus 1 or minus 1. Okay everyone, so the first pair that we can see is 1 into 12. Okay, if we divide 1 into 12 by 13, the remainder is how much? The remainder is minus 1. Okay, now the second pair is 2 into 6. Okay, 2 into 6 is 12. If we divide 12 by 13, the remainder is how much? Again it is minus 1. Then the next pair is 3 into 4. Okay, 3 into 4 is 12. If we divide 12 by 13, the remainder is again minus 1. Okay, then the next pair is 5 into, okay, 5 into what we can do? 5 into 8. Okay, 5 into 8 is how much? 40. If we divide 40 by 13, the remainder is how much? The remainder is plus 1. Okay, so we done with 1 2 3 4 5, then 8, then 12. Okay, the next is 9 into 10. Okay, 9 into 10. So if we hold on just a second, okay, sorry, just a second. So the next is 9 into 10. Okay, 9 into 10 is 90. If we divide 90 by 13, the remainder is how much? Minus 1. Okay, 13 7s are 91. So if we divide 90 by 13, the remainder is minus 1. Okay, now the next is what? The next is 7 into 11. Okay, the next is 7 into 11. We done with 6. Okay, now 7 into 11 is how much? It's 77. Okay, now 13 into 6 is 78. So if we divide 77 by 13, the remainder is going to be minus 1. Okay, so the final remainder is going to be how much? The final remainder is going to be minus 1 into minus 1 5 times into plus 1. Okay, so the final remainder is going to be how much? The final remainder is going to be minus 1. Okay everyone, so after dividing it by 13, the negative remainder, okay, the negative remainder is minus 1. Okay, so the positive remainder is going to be how much? The positive remainder is going to be 13 minus 1, that is equal to 12. Okay, so this method will always work. When the denominator is a prime number and the numerator is a factorial of 1 less than that prime number. Okay, so from this we can derive one rule. The rule is what? The rule is okay, let me write this here. Okay, if p is a prime number, okay, p minus 1 factorial divided by p. Okay, p minus 1 factorial divided by p, the remainder is always going to be how much? The remainder is always going to be p minus 1. Okay, so 12 factorial divided by 13. Okay, 12 factorial divided by 13, the remainder is going to be how much? 12. Okay, if p is a prime number, okay, if p is a prime number, p minus 1 factorial divided by p, the remainder is going to be how much? P minus 1 itself. The condition is what? P has to be prime number. Okay everyone, so let's move ahead. Okay, now the next is the remainder of 11 factorial divided by 13. Okay, we can follow the same method. Okay, as per the last question, we can follow the same method. We can find the remainder here. Okay, but now over here we'll solve this question by some another method. Okay, now in the previous question we found out the remainder of 12 factorial divided by 13. Okay, now can I write remainder of 12 factorial divided by 13 as remainder of 12 divided by 13? Okay, remainder of 12 into 11 factorial divided by 13. Okay everyone, so now look here. So over here the remainder of 12 factorial divided by 13, okay, we can write it as remainder of 12 divided by 13, okay, into remainder of 11 factorial divided by 13. Okay, so as per our previous calculation, the remainder of 12 factorial divided by 13 is how much? 12. Okay, remainder of 12 divided by 13 is how much? 12. Okay, into remainder of 11 factorial divided by 13, we don't know. Okay, so 12 is equal to 12 into which number? Okay, 12 is equal to 12 into which number? That is 1. Okay, so in this box there has to be 1. Okay, so from this we can see that the remainder of 11 factorial divided by 13, okay, the remainder of 11 factorial divided by 13 is going to be how much? 1. Okay everyone, so now the second rule is, if p is a prime number, okay, if p is a prime number, the remainder of p minus 1 factorial, the remainder of p minus 2 factorial divided by p. Okay, so remainder of p minus 2 factorial divided by p is always going to be 1. Okay, over here 13 is a prime number, and 13 minus 2 is how much? 11. Okay, 13 is the prime number, 13 minus 2 is 11. So 11 factorial, that is 13 minus 2 factorial divided by 13 is going to be how much? 1. This is our second rule. Okay, now let's have a look at third example. Okay, third example is, we are supposed to find the remainder of 10 factorial divided by 13. Okay everyone, the remainder of 10 factorial divided by 13. Okay, so now as per our previous calculation, we know the remainder of 11 factorial divided by 13. Okay, the remainder of 11 factorial divided by 13, we can write it as remainder of 11 factorial, the remainder of 11 into 10 factorial, okay, divided by 13. So over here the remainder of 11 factorial divided by 13 is equal to how much? Is equal to the remainder of 11 divided by 13, okay, into remainder of 10 factorial divided by 13. Okay, so as per our previous calculation, the remainder obtained, okay, the remainder obtained when 11 factorial divided by 13 is equal to how much? Is equal to 1. Okay, now the remainder of, look here, the remainder of 11 divided by 13 is equal to how much? That is equal to 11. Okay, into remainder of 10 factorial divided by 13 is how much? We don't know. That is what we are supposed to calculate. Okay, so 1 is equal to 11 into which number? Okay, so in this box there will be a fraction, but remainder cannot be in a fraction. Okay, so we can change the numbers. How we can change the numbers? Okay, after dividing it by 13, the remainder is how much? 1. Positive remainder is 1, means negative remainder is how much? Negative remainder is minus 12. Okay, is equal to, after dividing it by 13, the remainder is 11. So 11 divided by 13, the remainder is 11. Positive remainder is 11. So negative remainder is how much? Negative remainder is minus 2. Okay, into this box. So minus 12 is equal to minus 2 into which number? Yes, now this will be integer. Okay, that is equal to how much? In this box there has to be 6. So from this what we can conclude is the remainder of, okay, the remainder of 10 factorial divided by 13 is going to be how much? Is equal to 6. Okay, so every time we are not supposed to do this calculation. Okay, every time we are not supposed to do the calculation. Over here the rule is what? If p is a prime number, okay, the remainder obtained when p minus 3 factorial, okay, divided by p is going to be how much? Is going to be p minus 1 divided by 2. Okay everyone, this is the rule here. So what I will do is, I will write all the 3 rules together. Okay, so let me write all the 3 rules together. The condition is, if p is a prime number, okay, if p is a prime number, then what we need to do, okay, then the rules are p minus 1 factorial divided by p. The remainder is going to be how much? The remainder is going to be p minus 1 itself. Okay, p minus 2 factorial divided by p. The remainder is going to be 1. Okay, and p minus 3 factorial divided by p. The remainder is going to be p minus 1 divided by 2. Okay everyone, for example, the example that we took is 12 factorial divided by 13. Over here 13 is a prime number. Okay, so the remainder is going to, so over here the remainder is going to be 12. Then 11 factorial divided by 13. Over here the remainder is going to be 1. Okay, and then 10 factorial divided by 13. Over here remainder is going to be 13 minus 1 divided by 2. That is equal to how much? 6. Okay, this is the Wilson's theorem. but this is applicable only when p is a prime number and in case of factorial. If p is not a prime number, then we'll see in some other videos. Okay everyone, we will have a look at few more questions on this concept. Okay, the next question on Wilson's theorem is we need to find the remainder when 57 factorial is divided by 61. Okay, over here 61 is a prime number, okay, and 57 is what? 61 minus 4 is 57. Okay, we don't have any formula for minus 4. Okay, we can derive it, but how many formulas we can derive? Okay, we know the formula of p minus 1 factorial, p minus 2 factorial, p minus 3 factorial. Okay, we are supposed to remember only these three formulas. Okay, not for p minus 4 factorial, p minus 5 factorial, and so on. Okay, so we know the remainder, we know the formulas only till p minus 3 factorial. Okay, what is that formula? Look here, remainder of 61 minus 3 factorial, okay, divided by 61 is going to be how much? Is going to be how much? Remainder of 58 factorial, okay, divided by 61. That is going to be how much? 61 minus 1 divided by 2. Okay, that is equal to 30. Okay everyone, so we know that the remainder of 58 factorial divided by 61 is going to be how much? Is equal to 30. Okay, so now can we write remainder of 58 factorial by 61 as remainder of 58 into 57 factorial divided by 61? Okay everyone, now we can write it as further, the remainder of 58 factorial divided by 61 is equal to what? Is equal to remainder of 58 divided by 61. Okay everyone, the remainder of 58 divided by 61 into remainder of 57 factorial divided by 61. Okay, by using our second rule which we saw in the first video. Okay everyone, so over here the remainder of 58 factorial divided by 61 is how much? 30. Okay, is equal to remainder of 58 divided by 61 is how much? 58. Okay, into the remainder of 57 factorial divided by 61 is how much? We don't know. Okay, so now 30 is equal to 58 into something. Okay, in that something box that will be the fraction now, but remainder cannot be in a fraction. Okay, so now over here we used positive remainder, so let's use the negative remainder. Okay, so this is equal to 30 as it is. Okay, over here after dividing it by 61, positive remainder is 58, so negative remainder is how much? Negative remainder is minus 3. Okay, after dividing it by 61, the remainder 58 and the remainder minus 3 both are same. Okay, 58 is a positive remainder, minus 3 is a negative remainder. Okay, you can use any one as per your convenience. Okay, so over here 30 is equal to minus 3 into in this box. Okay, now this box will be having what? Which number? Okay, this box will be having minus 10. Okay, 30 is equal to minus 3 into which number? 30 is equal to minus 3 into minus 10. Okay everyone, so over here we can say that the remainder of 57 factorial divided by 61 is equal to how much? Is equal to minus 10. Okay, so minus 10 is a negative remainder here, so what will be the positive remainder? Okay, 61 minus 10, that is equal to 51, is a positive remainder. Okay everyone, this is how we can solve this question. Now let's do one more question. Okay, the question is find the remainder when 16 factorial plus 91 is divided by 323. Okay, the question is 16 factorial divided by 16 factorial plus 91 is divided by 323. Okay, so 323 is what? 323 is 17 into 19. Okay everyone, 17 into 19. So over here we need to use Chinese remainder theorem. Okay, over here we need to use Chinese remainder theorem. Okay everyone, so in Chinese remainder theorem what we do, we split denominator into co-prime pair. Okay, so 323 is nothing but 17 into 19. So over here the first step is we are supposed to find the remainder of 16 factorial plus 91, okay, divided by 17, and then after that we are supposed to find the remainder of 16 factorial plus 91 divided by 19. Okay everyone, so now let's find it out. Okay, so now let's find it out when this term is divided by 17. So over here this remainder is equal to what? Tell me. This remainder is equal to remainder of 16 factorial divided by 17, okay, plus remainder of 91 divided by 17. Okay everyone, so by using Wilson's theorem, the remainder of 16 factorial divided by 17 is equal to how much? 16, okay, plus remainder of 91 divided by 17 is how much? 17 5s are 85, so the remainder is 6 here. Okay everyone, so 16 plus 6 is equal to how much? 22. But we are dividing it by 17, so whenever we divide a number by 17, remainder has to be less than 17. Okay, so this number is more than 17, so let's divide this again by 17. Okay, 17 ones are 17 and the remainder is 5 here. Okay everyone, so 5 is the final remainder. Now over here remainder of 16 factorial plus 91 is divided by 19. Okay, so first of all we need to find the remainder of 16 factorial divided by 19, okay, plus remainder of 91 divided by 19. Okay everyone, so 16 factorial when divided by 19, 19 is a prime number. Okay, 19 minus 3 is 16, so p minus 3 factorial divided by p, where p is a prime number. The remainder is how much? P minus 1 divided by 2. So 19 minus 1 is 18 divided by 2 is how much? 9 is the remainder here. And we know 19 into 5 is 95, so over here the remainder is minus 4. Okay, so 9 minus 4, the final remainder is how much? The final remainder is 5 here. In both cases we got 5 as a remainder. Okay, so now we are going to use Chinese remainder theorem. Okay, the final remainder is going to be which kind of number? Let's try to identify. Okay, final remainder is going to be a number. Okay, let's have a look at it. Final remainder is a number when it is divided by 17, remainder is 5, means that number has to be the multiple of 17 plus 5. Okay, and the same number when divided by 19 should give 5 as a remainder, means the same number should be in a form of the multiple of 19 plus 5. Okay everyone, so just by looking at this we come to know that if we keep a is equal to 0 we will get 5, if we keep b is equal to 0 we will get 5. Okay, so 5 is the smallest number which satisfies both condition, so our final remainder is going to be 5. Okay everyone, the next question is we are supposed to find the remainder when 209 factorial, okay, is divided by 422. Look here, 209 factorial is divided by 422. Now 422 is what? It is 2 into, it is how much? 2 into 211. Okay everyone, and 211 is a prime number. Okay, so now over here we need to use again Chinese remainder theorem. Okay everyone, we are supposed to use Chinese remainder theorem here, so let's use it. Okay, so first of all what we are going to do is let's divide 209 factorial divided by 2. Okay, and after that we are going to divide 209 factorial divided by 211. Okay everyone, and let's find the remainder. So over here 209 factorial is how much? 209 factorial is 1 into 2 into 3 into 4 into so on till 209 factorial. When we divide it by 2, 2 and 2 will get cancelled out. Okay, so whenever the denominator gets cancelled out, the remainder is always 0. Okay, so over here when 209 factorial is divided by 2, the remainder is going to be how much? 0. Okay everyone, now 211 is a prime number. Okay, 211 is a prime number, and 209 factorial, it is 209 factorial divided by 211. Okay, so 209 factorial is how much? 211 minus 2 factorial divided by 211. Okay, so over here the remainder is going to be how much? P minus 2 factorial divided by p, where p is a prime number. Okay, the remainder is going to be how much? 1, by using Wilson's theorem. Okay, now how to identify final remainder? Let's have a look at it. The final remainder, okay, final remainder is going to be a number. Okay, final remainder is going to be a number which when divided by 2, remainder has to be 0, and which when divided by 211, remainder has to be 1. Remainder is going to be a number which is a multiple of 2, plus 0. Okay, and final remainder is going to be a number which is a multiple of 211 plus 1. Okay everyone, so the final remainder is 2a plus 0, and final remainder is in which format? 211b plus 1. Okay everyone, so basically first condition says that the final remainder has to be even number. Okay, and the second condition says that final remainder should be in a form of 211b plus 1. Okay, so if I put b is equal to 0, the value of remainder is 1, but it is not a even number. If I put b is equal to 1, it is 211 plus 1, 212. Yes, 212 is a even number. Okay, the smallest possible number which satisfies both condition is which one? 212. Okay everyone, so final remainder is going to be 212.